In this problem, we have a vector field f of xy equals xy squared I minus x square root y, and then there's no way the j would ever be underneath the square root. So the square root y is separate, and then j, and then r of t would be, that's the curve you're integrating over. That's your c. It's one representation of it anyway. And that has components t cubed I and t squared. Well, it has components t cubed and t squared. T running from 0 to 1. So let's write down, okay, the generic formula for the integral with respect to the vector field looks like that. Integral over c f dot dr. And the computational formula then, we write the computational formula down with the understanding that you've parameterized, or it's in terms of a parameterization. It's in terms of r of t. Then we end up integrating from, well, it's going to be 0 to 1 here, right? But in general, I'll say a to b, right? And a is going to be 0 and t is 1. That's nice when it's given to you. And then the computation formula, you actually write f in terms of t. I'm just going to write down f, though. But you have to do, it's a single integral, right? It has to be in terms of one parameter. That's one way to remember it. And then dotted with, it turns out, when all is said and done, that it becomes r prime of t dt, right? So that would be your other interpretation of dr. Now, why does that make sense? Because just going from the Leibniz form to the prime notation form, that might be the easiest way to remember what dr is, right? Oh, then you just multiply both sides by dt and you get this. Okay, so I was trying to give you an easy way to remember it, and I kind of blew it, but that would be the easiest way. Does that make sense? Okay. So that's our calculation formula. What does it tell us to find? Okay, let's do it. What is r prime of t? 3t squared I plus 2tj. And what do we do with that? We dot it with f. Now, eventually, we have to parameterize f in terms of just what x and y are on that curve, right? So in terms of t. But if you want to, you could just take the f that's given. F is xy squared I minus x square root yj, and do the dot product first and then make the substitutions, right? So this guy times this guy, and then these guys multiply together. So what do you get then if you do it that way? F dot r prime. So it's 3t squared xy squared plus, right? The dot product is always a scalar quantity, right? Plus what? So yeah, you want to change it to negative, okay. Minus 2t x square root y, right? No i's and j's involved. You're multiplying corresponding components, adding them together. That's the dot product, right? But then if you haven't realized it already, okay, you can't have x's and y. You got to have one parameter, and it's usually t, right? So now you just have to be careful with your substitutions and know what's what. In this is, okay, your parameterization is given to you. So in that sense, it's a really straightforward problem where if you're going to mess up, it's just going to be algebraically. If you understand what's what, right? Because what's x here? On the curve, x is t cubed. Y is t squared. So the thing that's going to mess you up is the laws of exponents, right? From algebra. So, all right, so this becomes, so that I don't mess it up, I'll write it out. 3t squared, I'm going to leave that alone. X is t cubed. I'll just make that substitution right there, right? Okay, wait, I think I can do this in my head. Y squared, that's t squared squared. What's that? T to the fourth. All right. Minus 2t. Okay, x is t cubed, so times t cubed. That's this substitution right here, right? And then the square root of y, square root of t squared. T is 0 to 1. You don't have to worry about a plus or minus, so just t there. Okay, then what does all this lovely stuff become? Okay, we've got to add exponents, right? Keep the base, add the exponents. 3t to the Let's see if I believe you. Yes. 2 plus 3 plus 4, 9. Yeah. And then minus what? Darn, it's not the same? I heard the fourth power. Is that right? Fifth. Okay. Okay. So, long story short, then, at least for the setup then for this integral is what? Integral from 0 to 1. That's what t goes from. And then your integrand, this dot product here, in terms of t, ultimately turned out to be 3t to the 9th minus 2t to the 5th dt. Would you buy that? What did that turn out to be? So obviously there's work to be done. Negative 1/3? 1 over 30. Okay. And it wouldn't be that hard to evaluate, would it? Especially since it goes from 0 to 1. Yeah. I'm going to let you guys do it.